Alrighty. It is Saturday night, about 11:30. The doggy is in tow. And looks like he's chilling with us. So here we go, folks. Another Jeter episode for us to sip our tea or our Coke Zero, get the popcorn out, and do some meandering. So today, let's talk about Prof. Ryan Marcus. Okay. I think Prof. Marcus says I can say he's my former joint student or boss. Or I was his boss. That sounds weird. I prefer mentor, my former joint student. There we go. Okay, we'll say that. All right. So today we are going to meander. And I really mean meander. We're going to go all over the place. It's going to be wacky, and it's going to go in strange directions. We're going to talk a little bit about my electronic unicycle and my shoulder. I've got pictures. We're going to talk about intermittent fasting and ketone IQ. That's right. I don't do sponsorships or advertising. Well, exception of early stuff, but come on, I kind of have to show that. But this thing, I'm not paid in any way to promote this stuff, but good stuff. Little expensive, but if you can afford it, really good on curbing your appetite and giving you energy. I'm going to have some more of this. I think I like it too much. It doesn't taste super great, but it's effective. Then we're going to talk about prompt engineering and that debacle. And then fast code, secure code, correct code, high quality code, which kind of brings us down the rabbit hole of Professor Marcus in a very interesting 7 degrees from Kevin Bacon kind of way. Our virtues for today. Goju needs to continually remind himself not to be judgy of others. I'm working on it. I meander toward that direction sometimes. I don't mean to. I don't. I'm getting better. I'm working on it. Something I am a little bit better doing is not taking myself too seriously. I think I don't know that I've mastered this, but yeah, I've become much more comfortable making fun of myself. And actually, it was, I think, my mom that taught me when I was just a wee little pup. She said, always be the first one to make fun of yourself, because then you beat everybody else to it, or something like that. And whether or not, chill, buddy, whether or not that's what's actually going on, I do think that when you don't take yourself too seriously, it does make it a lot easier for you to stay humble and make mistakes and not be embarrassed by those things, or not as much, and just kind of like accept that we're all humans and strive to be better. Because the big thing, just as an aside, the big thing about embarrassment, I think, is it's not so much that you get embarrassed in the moment. I think many of us can experience that. It's the after effects. It's the shock waves. It's the fact that this can create massive analysis paralysis. It can be debilitating because you become traumatized by that last experience of being embarrassed. And now you don't want to experience that again. And so you stop doing stuff. You stop taking risks. You stop doing podcasts. You stop submitting papers that get rejected. This one didn't get rejected, but what is this? Oh, okay. But many of the other papers I've been on have been rejected a whole bunch of times. So many VCs told me and Merle to take a hike, and a lot of other things. So, but when you don't take yourself too seriously, one of the beauties is I think you can disconnect yourself from your actions. That while I think it's good to be accountable and responsible for your actions in some ways don't define you. And so if you make a mistake, it doesn't mean that you're a mistake. If you have a failure, it doesn't mean you're a failure. That's just the part of life. And so one of the big things that I think is actually super important in these virtues is that this one, not taking yourself too seriously, I think this is one of the biggest keys to failing and not becoming so overwhelmed and so, oh, everyone's watching me. And now you're super self-conscious and you're frozen in fear. And now you're never going to go outside again. And the truth is, I think as many of us know, those of us who have been going out and failing in the public and on the world stage in perpetuity, what I think most of us know is, yeah, people are not really watching other people. They're mostly just watching themselves. And this is not to say that, sorry, I think it's just raining. Yeah, I think it just started raining. So this is not to say that you should be careless. You should definitely strive to be responsible and not do bad things, all of that stuff. But know that there's this great quote. I think it talks about how part of what? Okay, sorry. Is this thing talking to me? It is. Okay. I'm playing this music in the background and I'm like, what is this? And we're just going to pause that. Okay. Too many. There we go. Lots of failures tonight. I think I'm going to leave this all in just for kicks and giggles. Anyway, what was I saying about this seriousness? So, when you take yourself very seriously, it can be debilitating because you're so focused on just being perfect. And yeah, maybe you are, but only in the two things you allow yourself to do, right? Like you only allow yourself to wake up and brush your teeth because you need to be perfect and you're too afraid to do something wrong for fear of embarrassment or being judged. Because oftentimes, right, like this is what I think is going on is like if we make a mistake, here's a way to think about this. This ties into the external validation. We'll put this in here too. Okay. So consider this scenario. You are doing a podcast and you're recording it and you're totally by yourself and you make these mistakes. and you're like, oh, I made these mistakes. And then you think, oh, well, I'm by myself. No one else has seen them. I'll just edit this out. And then you kind of just like keep going, right? It's sort of like not a big deal. Why is it then that when you have the same type of behavior, but instead of it you being by yourself, now it's in a space where it's a live audience, and then your behavior is somehow totally different? That the chill you that was totally fine making the mistake and was like, yeah, I just edited it out, blah, blah, blah. That is cool cat, super smooth. That person is gone. That now you made the same mistake, but suddenly because there is an audience, you somehow you're frozen, or you lose your concentration, or you lose your cool, or something of that nature, right? Why does that happen? I think it's kind of happening because of this thing. Because if you didn't really rely on external validation, and you really were okay with yourself, and you were okay with, yeah, not taking yourself too seriously like you were when you were recording the podcast or whatever by yourself, then in a different environment, and I get it, right? Like people around, there's certain things that you should and should not do. But let's just assume you made like a minor mistake. It wasn't, you just said the word super 4 times in a row, which is what I think I did in last night's episode. And I think I left it in on purpose. Or you're in the middle of a sentence and suddenly you're hearing weird voices and you lose your focus. Like I just did that momentarily ago. Why would those types of small mistakes in a private setting, which most people would probably be okay with and be like, no big deal. I know me and it's fine. But then in a public setting where there are eyes on you, it's suddenly totally different. A lot of it, really, if you get at the crux of it, it's really our ego. It's really our own insecurity. And it also is quite strange because oftentimes people are not really paying that much attention. I mean, maybe your partner is or your best friend is, but the rest of the world is probably doing their own thing. Even for people that are watching GTT, that literally are playing this right now, I can almost guarantee you 80% of you cheaters are playing me in the background, or you got me on your phone while you're working out. You're multitasking, and I'm the secondary voice. And maybe your focus shifts, so you're focusing now because I just called you out on it. By the way, mostly in a playful way. Like I do the same thing. I have stuff like I just had that thing in the background, right? I'm not really paying attention to it. It's called like the third screen or something. So the point is that even when you're being recorded and you're on stage, half the time people aren't even paying attention in that case. So if you make a mistake, like just roll with it. Just, ease off the trigger and roll with the punches and be calm. Be relaxed. Take a deep breath. Speaking of which, I have a thing. I'm really going down a detour. I'll circle back to that. Anyway, these are our virtues, and don't take yourself too seriously and avoid relying on too much external validation. And the truth is that these things this isn't meant to be like, oh, without this, you're just buttoned up too tightly, or you're a stick in the mud, or whatever the silly things are. No. These things, the reason why I harp on these things is I believe, it's been my experience, that these things, without doing these, they limit growth. That's why I care about them. Because like I'm all about growth. As much growth as I possibly can. Work with the most amazing people I can, like some of the folks here. This guy, super incredible. I don't really know Muhammad, but I hear that he's really fantastic. And this guy right here, this just, yeah, huge fan of Kraska. Huge fan. He's actually an investor in Merle. And he wrote this paper that I loved. And a case for structures. Yeah. Case for learned index structures. This, I think. I really like this paper, especially the time it came out. A lot of people were in this state of disbelief with machine programming or doing like AI and software. And I was trying to convince people, this was back in like 2015, 16, something like that. I was trying to convince people, and everybody was like, no, that's not how you use machine learning, which in their defense is true. At the time, it was mostly for like NL and computer vision and stuff. But I mean, like, if you understand the technology, why couldn't you use it for the next thing? So anyway, I was trying to convince a lot of folks that this is the future. And one of the papers that really helped me, and which I'm infinitely indebted to Kraska. I don't even know if he knows this, but maybe someone will let him know. I'm talking about him on this channel. I'm a super fan, very good friend with Kraska, but his paper is one of the key reasons why I was able to convince a lot of people at Intel and many other universities that this was the future. And I don't know if I've spent a ton of time with Kraska talking about a bunch of things, but I'm not sure if I ever shared that story, and a true story. So anyway, going back to these, not taking yourself too seriously and avoiding relying on too much external validation, these are really, in my mind, meant to accelerate growth. That's really, from my perspective, that's kind of the lens that I'm thinking about. I'm not saying it so you can be a better person to be around with your friends, although I do think that will be a natural byproduct, because I do think that people are naturally drawn to people who aren't like super buttoned up to where they can't laugh at themselves. And if you don't believe me, watch Dungeons and Dragons, something. I don't know. And keep an eye out for the Paladin, which is a bit of a bummer because when I was a big D&D player, before I kind of switched to perpetual, like battle mage, wizard, that kind of thing, I was a paladin. I was like always a paladin. And so I just thought paladins were awesome. Now, I would never be like lawful good. That felt way too overboard. But I think you could do some things. Like in Notica, I kind of changed it up where you could be, this is like chaotic good, where you're like good, but you're willing to kind of, it's like Batman a little bit, right? He's good, but sometimes he does some bad stuff that it's like, is he really a paladin? Maybe, as long as the end is all you really look at, maybe. So anyway, in this Dungeons and Dragons movie, this is the movie, there's this paladin in here, and he's like, yeah, he's the best at everything, fighting and inspiring, and all of the different weapons, and just all kinds of stuff, except for like his charisma. His charisma's like a solid 0 or something, and it's just kind of stick in the mud. And he's a really good example. this guy I think takes himself way too seriously, and they make fun of him throughout the movie, and I think rightfully so. So the point is, like, maybe let's not be that paladin. Let's you don't have to go uh, off the deep end, but being able to poke fun at yourself or laugh when you make mistakes, I think can be really, really helpful. So you can kind of get over your own ego. This used to actually really be this. Uh, oh, sorry, I can't speak tonight. Uh, Disabilitating. Uh, I'm not saying that word right. Debilitating. Debilitating. You guys know what I'm trying to say. That used to be a real problem for me when I was younger, and then I don't know. I just learned to kind of chill out a little bit. Okay. So these virtues, and then we're also going to just do our normal meandering, but more so uh, tonight than in other podcasts, VODs. Okay. Technology that really kind of annoys me. I got to be honest. Poor quality code, poor quality software really annoys me. I mean, like, just really annoys me. I don't know why we allow the software that exists today to be so bad. And it can be so much better. It really can. And so that's part of my goal with machine programming. Part of the drive with machine programming is to help us make the quality better. And then eventually make like the user interface and stuff better. But it's like, you know what it's like? It's like it's like when we first started creating music, I think. And this is probably going to be a little bit sacrilegious to some people that are like hardcore music fans for like old school stuff. But if we can just be intellectually honest for a moment, I think that there was, well, I don't know, maybe there's a period of time now where it's still kind of bad. But when I listen to some older music, it can feel very kind of like like shallow. It doesn't have like depth, or it doesn't have this kind of spatial feel. Maybe a better example rather than music, where people will probably get super bent out of shape. Maybe let's switch over to movies. Okay, so back before we had color and sound and all of that stuff, we had sort of like these black and white picture shows, right? And we see them and we kind of look at them and we laugh and say, huh, like, oh, that's so cute. And gee, weren't those funny times? And then we go to where we are today and we don't do that. And we don't even do that kind of like as a joke, because we've evolved so much with movies and creating media. We're so much more advanced technologically that to do something like that, especially like in perpetuity, like we did it every time, people probably like would not watch our stuff. I think there's a couple newer kind of movies or shows where people will do like the black and white thing, but even then, I don't think that they'll go full silent. And I feel like Tarantino and others, like I think they did a throwback maybe to some like the horror, like the it's something 5,000, like horror show 5,000, or I'm not getting the name right, but like these throwback type of things. But even those that are meant to be a little gritty and like poor quality for recording, they're still actually like quite good. And so this is kind of how I feel about software today. I feel like many of these systems, it's like we're doing the black and white movies with no audio. But the problem is we have the technology to not be doing the black and white movies with no audio. We do. And you know that we do because we have things like Linux or Git. I'll just use those two since I think there's others that I could mention. Maybe the Android operating system. That's sort of a variant of Linux to some degree. And then you have other things like certain pieces of software like Elden Ring or Baldur's Gate 3, right? Okay. So there are 4 pieces of software that demonstrate incredibly high bars for quality and just amazingness. Those data points are there as substantiation that we can build really incredible software that is fast, that's reliable, that does amazing things, that are almost universally praised as just being outstanding. So if we can do it, why is it that like 80, like let's take this Adobe Acrobat thing. I don't know what is going on over at Adobe. And, you know, some of my friends are over at Adobe. I think Dave Abrahams is over there. And I think Alexander Stepanov, the guy who created STL, was the standard template library for C++. He was over there at some point. Maybe he still is. These are people that know how to create incredible software, right? And on top of that, PDF is sort of like this universally accepted format. But recently, what I've noticed with Acrobat, and I think other people have as well, is you would launch it, and then for the first 10, 20, 30 seconds, it's unusable because it's decided it's going to check for updates, right? Totally get it. Absolutely. Check for updates, all that. But here's the thing. Use multiple threads. There's this concept in programming where you separate the user interface thread from various worker threads. And there's probably a specific name for this. And it's, I'm blanking on it tonight, probably from my wild EUC ride, which we'll get into in a second. But when you employ this technique, you can use the software while it's doing big stuff in the background. And in fact, most of the software systems that are very user-friendly, they do this, that you don't even know that this stuff is going on. You're just allowed to move forward. So how is it that a behemoth like Adobe in their flagship product, which is Acrobat, or one of their flagship products, I mean, Adobe Premiere Pro is probably another, but how is it that something that's used so ubiquitously could be designed in such a way that they think, oh, it's fine for when people launch it for 30 seconds or whatever. And by the way, this is on my machine, which is like an i9 13th gen Xeon processor. I think I've got 128 gigs of RAM. I mean, this is a serious Goju machine. This is not like a $300 Chromebook. So no disrespect, Google. But those people that are not running on super high-end laptops, how long does it take them to start up? Probably much, much longer. So how does Adobe think that that's acceptable? I think that we've gotten to this state where what can the consumer do? What can normal people do? I mean, Adobe essentially owns the space of PDF, and there are competitors with Acrobat, but I think they're kind of like pretend competitors. At least when I was looking for alternatives several years ago. Maybe things have changed. And so you don't like have a monopoly, but you basically have sort of monopolistic like behaviors because they don't need to improve the quality to stay in the premier space in industry because there's essentially no alternatives. And when you have that type of monopoly, this is one reason why there's many reasons why monopolies are not good. This is one reason is that one, monopolies tend to stifle competition. So you don't have people being able to compete. And when you don't have people being able to compete, then you often don't end up with best in class types of things. So you want to avoid monopolies as much as possible. You really want like a free market where people can compete and sort of the best thing wins, which is Linux, right? I think, yes, I'm using Windows here, but on my phone, uh, it's running Android, and I do a ton of stuff I think we all do, right? And Linux is not a monopoly, and they were super small and they were a nobody, and then they just sort of overtook the space. Why? Because they were just better. It's just more reliable. I mean, once Linux has like a better development environment and can effectively run Steam, and the truth is, you gamers that are watching this, we all know it can a little bit. Why do I say that? Steam Deck. That guy's running Linux. And so it's, I think, like the Steam version. So is that mainstream? I don't think so. Not yet, but I think we're on our way. Anyway, so this really annoys me because I feel like we can do better. And there's evidence that we can. Like, it's not just me saying this, saying we can do better. Just do better. It's like, no, there's a ton of evidence that shows we can. And then we don't. And oftentimes the spaces when we don't, it's like the incumbents, like Adobe and Microsoft at times. Not all the time. Some stuff with Microsoft I think is really awesome. Other stuff, like my machine just freezing and dying, and the CrowdStrike stuff that was shutting down airports. And look, I don't. I do not blame CrowdStrike. We can go down this rabbit hole, but there's a way to set up a system to where if it's continually rebooting, the system automatically is keeping track of that information, like at the hypervisor or below level, where it has these counters before the operating system loads. And then it sees that it can't boot up properly. It just defaults into safe mode. Like, seriously, guys, this can be done. We all know it can be done. Let's not pretend. Okay, it's not CrowdStrike's fault. I mean, it is to some degree, but it's, yeah, there's many, yeah, there are many analogies I could use here, and I won't use them because I'm probably already burning way too many bridges. Look, and just to be clear, I'm not saying that Adobe is a bad company or Microsoft is a bad company. I think that many of these companies do amazing things. PDF is one of the most amazing sort of inventions that we've had, right? I mean, it allows us these portable document files, and that's super valuable and so awesome. But like, let's not go. We're so focused on some of this stuff that we forget to make the basic stuff, the core stuff, the stuff that people use every day, make that stuff work properly. And I don't think that's acceptable. I think that's where I kind of draw the line, is that stuff needs to be first and foremost. And then all this other stuff, that's just icing in some sense, right? Like having Windows support for Copilot and all of this and like their recall thing. Woo! Microsoft recall. If you don't know what it is, Google it. Ooh. I mean, I was hearing about that before it came out, and I was like, oh, that is not going to go over well. And I think it's been mostly yanked, but talk about a really not super great idea. I don't know how some of this stuff gets approved, but so you've got these things that are all like bleeding edge, whatever, feature creep type of add-ons to somehow make things more fancy. But then you have things like CrowdStrike. And if the operating system doesn't even load, or Windows, for example, decides that, oh, it's time for you to do this update, I'm just going to shut down and do this update. Like, no, I'm sorry, no, you don't just get to decide this. There is like, I appreciate the fact that you may think that you can do these types of things, but if you do such sort of bad behavior things, you will alienate your entire customer base. And I'm not trying to get on a soapbox here. I'm just trying to speak truth to power to some degree. Not great, right? You can't do that. Like, what if people are this is a critical system? Like there's an episode in Space Force where they're making fun of this. It's actually quite funny. I think if you Google Space Force and F Microsoft. By the way, it probably sounds like I'm really beating up on Microsoft tonight, and that's not my intention. Look, I'm using Windows, right? We use Visual Studio, right, and Outlook and stuff. I think Microsoft does a lot of great things, but I also think Microsoft does some stuff that's not super great wins. But some of them, this is the part that's crazy. They could be so easily avoided. Okay, let me give you another one since we're going down this path. This taskbar, or whatever this thing is called, it's called a taskbar. Yeah, taskbar. From Windows 10 and before, I believe you could move this. You can move this to the left or to the right. So, Goju, being all about optimization, right? Like I type in Dvorak, right? See these keys? These are not the keys that show up on a QWERTY keyboard. Why? Because I think that Dvorak is better for reducing carpal tunnel. That one's, the data on that is almost definitive. I also, at least for me, anecdotally, I type almost 2 times faster in Dvorak. And I'm not trying to create a debate or anything, but those 2 reasons, I think it's for me. Okay. Now, how is this relevant? I'm about doing things that will optimize. I'm trying to optimize, maximize. Okay, so check this out. Here's the screen we have right now. You'll notice something. The entire vertical space of this screen is being used. It's being used over here. It's being used over here. But you know what's not being used? The entire horizontal space. Why? Because I have a lot more horizontal space and I need to do more things with vertical space. So one way that I could get some extra vertical space, and we all could, is if I could move this taskbar over here or over here, which is what I would do. And now it may seem like a minor thing, but I get 5% more vertical real estate doing it this way. I do. And so if you think that these kinds of things don't matter to me, let's go into Early Mentor. And see that we're trying to, like, they push this all the way to the top. Thank you, Val. That rocks. I still think there's a little too much vertical space here that's being wasted. Notice that it's going all the way to the bottom, right? And then on top of this, I really am not a fan of these horizontal tabs. But what you'll notice is that once you go into Mentor, vertical tabs. Why vertical tabs? Because one, vertical tabs can go all the way down, right? And the second is we tend to have significantly more of this horizontal space, right? Because most of our monitors are like 16 by 9 or whatever. Are we using it? In many cases, no, because we read up and down. But we do things like this side of the screen, that side of the screen. So, Microsoft, why did you make it so you can no longer move the taskbar to the left or the right? And I haven't tried recently, but believe me, when Windows 11 came out, I literally would not upgrade. I wouldn't use it because of this thing. And it may seem like it's something that's silly, but look, that's 5%, 7% of the screen real estate that I don't get to use every freaking day. Every day. So, Windows Copilot, Recall, all of this other stuff. You know what I'd like? Simple things, the basic stuff. And not to make a shout out to Apple, but I'm going to do it. Mac OS, guess what? That thing you can put wherever the heck you want. And when I used to use Mac OS, it would sit right over there, specifically over on that side. And in fact, when Urs and I were first creating Merly, he was coming over and staying with me. And we were doing like these hackathon sessions. And he noticed that my toolbar, my taskbar was off to the side because I was still using Windows 10 at the time. And he was like, why do you have it there? And I was like, oh, more vertical real estate. Like, especially when you're looking at code, right? Code that goes up and down, right? And now, here's the thing. Now that you know, in case you weren't thinking about it before, like the whole YouTube back button, now that you know, it's going to be one of those things where it's going to be very hard for you not to know. Because, see, like, look at this space. See this space right here? This is not being used. So we could just move this over, this could shift, and it wouldn't change anything. But the vertical space, I mean, it's pretty much all being used. So it's the little stuff, right? It goes back to this point about mastering the basics. It's in here somewhere. I think. Master the basics. Master the basics. And why is Linux the most used operating system in the world at this point? I think they've mastered the basics. I haven't heard of like a CrowdStrike type of thing happening with Linux, where all these airports have been shut down. Now, it's not. I'm not trying to say that like Linux is perfect. I mean, the XC backdoor exploit, obviously, that happened. There's been other stuff like OpenSSH, Heartbleed, I think. Maybe it was OpenSSL. I can't remember. Let's look that up. Curious. Let's see. I think OpenSSH. Is it? Oh, this thing again. Okay, cars. Okay, guys, let's do this together. That's a car. I mean, it has a bus, but there's a car too. Okay, car. These are lights. No cars. I don't think any cars. Who knows? Okay, what do we got? Okay, open SSL heartbleed. Yeah. Um. So yeah, that was not super great. But and why am I talking about this? Uh, just open source, right? Because this would be one of the arguments, and uh, yeah, it's tough, right? Trade-offs. So again, not really trying to point the finger, although I probably feels like I am, but instead I'm more just trying to drive home the point that when you really master the basics, I think that you're going to get maybe 90% of the way there. And then at that point, sure, like the other 10%, let's focus on those and let's add some icing and things. But if you become so obsessed with the 10%, the icing, and oftentimes this is kind of what I see in the world today. In fact, this is probably a great segue to go right into prompt engineering. Is uh, prompt engineering, I think, is a great example of this 10%. It's not the basics. They're trying to essentially figure out how to communicate with the AIs so you get these sort of like reliable outputs. But here's the thing: language models are stochastic machines, and writing prompts is not an engineering process, as we've discussed in prior episodes. This is first of all, this is super hypey because you're overloading this word that actually means something quite important, and you're using it in, I think, a fairly disingenuous way. I really don't like when the hypey folks do this, because this isn't engineering. Engineering is essentially this process of using known, well understood techniques to achieve some commonly reproducible, a repeatable outcome. It's like civil engineering, chemical engineering, software engineering, is that you're doing stuff that you know has worked in the past to then build something for the future. And it's engineering because you're using these practices that are essentially deterministic. They're reliable. They're usually based on STEM: science, technology, engineering, mathematics. And most of those things, not all of them, most of those things are deterministic. They are not stochastic. Some of them are, right? I get it. Like in this quantum space and entanglement and other weirdness, you have things like transient faults. And yes, there's some weird stuff. Okay. But oftentimes you can even get those stochastic things and force them into deterministic behavior, like the on and off signal for transistors, right? This is also a somewhat stochastic thing. It's not, as some of you who are experts in computer architecture and like the actual physical level of computing devices know, it's not a binary switch. It's actually analog, right? It's essentially this threshold. And so what we do is we have this sort of middle space that says, we don't know, unknown. And then once it reaches, at least this is my understanding, if there's somebody with a PhD in the electrical engineering that wants to chime in and correct me, that's totally fine. But when I was learning this, is that it's an analog signal, and once it reaches a certain clipping point of the upper bound, let's say maybe 70%, 70 to 100% says it's on. And then when it gets to a clipping point toward the lower end, let's say, I don't know, 25% or below, then it's off. And so anything in this middle range is like, I'm not going to say anything because there's no deciding point, right? That is an example of a system that has stochasticity, but it's controllable because you know that if you wait long enough, the signal will dissipate and you can say it's off. Or if it is getting a signal, the threshold will rise enough with the electrical throughput that it'll reach the clipping point and it'll be on. So you can take a system that is sort of quasi-stochastic and then make it non-stochastic, make it somewhat deterministic. Language models are not that. Language models, and in particular, due to the wide variability of the models themselves, even if you had a language model with whatever, the temperature turned all the way down or something, even if you had that and you got fully repeatable answers from your prompt engineering, then if you take those prompts, which supposedly you've engineered, right? Supposedly this is like you've created a screw. And so you can screw the screw in and it works great. And you can take the screw out and say, oh, I'm going to go to another hole and I'm going to put the screw in over here because this is a universal thing. You try that with your prompts, it's not going to work. It's not going to work reliably anyway. You're going to take this and use it for company A's models. Maybe it works perfectly. Probably not. It's probably still going to be stochastic. But let's just pretend there's some universe where it does. Then you take that thing that's supposedly the golden perfect prompt, you put it into another model, the answers are totally different. And then you just keep doing this, right? Now, if you take the same type of thing and you have a prompt that you put into something like this, right? And you do something like this. And now you go to all the different embodiments of this thing and you provide that same input, that same prompt, you are going to get exactly the same answer. This is engineering. This is what engineering looks like. This is not engineering. This is something else. So why am I harping on this? Well, I really don't like hype. I really, even if it's in an area that I'm working on, I don't like it because it ends up creating far more work for me and those of us that are trying to do the right thing, because now we have to do damage control when all these things kind of fall apart. And you may be saying to yourself, well, prompt engineering, that's, not going to fall apart. That's like this incredible thing. And that's like a job and people do this now, right? Or maybe they don't. This came out, I saw this from the Wall Street Journal. I saw it today. Well, I guess it's now the 27th, but I saw it on Saturday. Now it's Sunday, but I guess it came out on Friday. So my feed's a little slow. Let's take a gander at what the Wall Street Journal has to say. The hottest AI job of 2023 is already obsolete. Prompt engineering, a role aimed at crafting the perfect input to send to a large language model, was poised to become one of the hottest jobs in artificial intelligence. What happened? Well, I can tell you what happened. One, it's complete hype and it's sort of just nonsense. And two, on top of that, it doesn't actually work because it is not this. I closed the calculator. It's not that actual engineering. But let's read some more. 2 years ago, prompt engineering was one of the buzziest jobs in tech, fetching salaries up to $200,000 on the promise of becoming any company's AI whisperer. Oh, it's so bad. And I don't even blame WSJ here, because I remember people calling it this. And I remember too trying to talk to some of the VCs that we work with and say, guys, this is nonsense. And some of them listened to me, and some of them had to find out from the Wall Street Journal, I guess. Now the role is basically obsolete thanks to the breakneck speed of AI development and companies' own maturity in terms of understanding and how to use the technology. That is patently false. Wall Street Journal. I could not disagree with this claim more. That is not the reason why at all, in my opinion. Sorry, I'm coming out of the gate swinging tonight. I don't know. Maybe I don't know why I'm so ornery. I think hype brings it out of me. So they say now the role is basically obsolete thanks to the breakneck speed of blah blah blah. That's not why. The reason why is, one, there is no such thing as the perfect prompt. It's not code, right? It's some magical nonsense that doesn't even do what it's supposed to do. And they're not engineers. This is not engineering. This is just nonsense. And before I go too far down this rabbit hole, I want to just take a moment to walk down memory lane and have us look at, was it over here? Yeah, this one. I want to take a look at this. And I want to say I really am not, I'm trying not to pick on anyone here. I really am. I'm specifically not saying any names, but there are people that are very smart people that I deeply respect and think are amazing that somehow got caught up into the hype of this and were saying like kind of a little crazy things that I know that they are smart enough to know is sort of like not true-ish. It's like people that try to argue that these foundations of mathematics are just things like perspectives. They're not sort of these actual truths. And minimally, while you could have an epistemological debate about these, if those truths didn't stand, then our entire infrastructure on society with technology would all come crumbling down. Very much like what we looked at last time with the number zero. If the number zero doesn't work the way that we think it does, or the way that we're using it, all of our financial institutes would fail. Airplanes would follow the sky. Hospitals would just stop working. The electricity in your house wouldn't work. This stuff has to obey those laws of mathematics and other scientific properties like physics. If they didn't, then we wouldn't have things like reliable power. I wouldn't be able to reliably create this thing. So there is a very real understanding of what science is. And I'm not saying it's like we know everything. We don't know everything. But there are certain things that we understand at such a deep level that we have yet to see deviations of these laws or these truths. And so we use them as the foundation of everything else. Like addition, that addition, adding two numbers together works the way that we've discovered. Mathematics existed. We just observed it. Nobody really invented numbers and addition, right? It is already there. We just have this is why a lot of people will say there's no such thing really as invention. It's just discovery. Maybe. But those things are the foundation of engineering because of their determinism. That's critical. And that's where you get into the space of engineering. So now let's take a look at this. And as we're watching this, I want to say again, I'm really not trying to pick on anybody. I might be appearing to be a little bit more vehement because I do. Look, here, look, it says right here, I need to not be so judgy, but I got to be, this is one of the reasons why I get judgy. I'm going to be honest, is when very rational people start behaving irrationally, it bothers me. I don't like it. That, like, for example, when I was being corrected on the foundations of, or the invention or discovery of zero, I didn't draw a line in the sand and say, no, I'm right. I know everything, blah, blah, blah. Like, because if I'm wrong, I want to be corrected. And then it turns out I was wrong. That's what I think a rational, logical person does, is they try to look at the situation, understand, did I make a mistake here? Is there a misunderstanding? Like, how did we get here? And so rational people will use reason, not emotion, to make their decisions. And so when you have strong rational arguments, this is the stuff I teach at the university on critical thinking. If you make a very rational argument that is founded in logic and substantiation, and people don't believe that, it goes back to Asmongold's thing of, you can't reason someone out of a position that they didn't reason themselves into. And I get that. I get that a lot of people are not using reason and they're just doing stuff. And generally speaking, those people are not in my inner circle. What I'm talking about are people that I know are super reasonable, people that I know are super logical, and they are buying into the hype and saying, like, no, prompt engineering this is the future of how we're going to create software. Oh boy. I mean, like, I care way too much to let this kind of stuff slide. Especially when some of these voices are the thought leaders in the space of software engineering, right? It's like if Linus Torvalds were to come out and say, yeah, the future of software is going to use prompt engineering, I would create a VOD and say, no, Linus, it's not. Because this is not engineering. And this is the thing that you're interfacing with is a stochastic machine. And so you can't staple on logic afterwards to make a system that is illogical logical. Hopefully it's starting to make sense on why I'm saying, like, you can't staple reason onto these systems that are not foundationally reasoning systems and somehow make them reason. It's the same reason why you can't do this with prompt engineering. Even if the prompts are perfectly correct and they're totally logical, you're interfacing with an illogical system. It's not going to make that system logical now. That system has to be logical at its base. That's the way all of this stuff works. That's the way science works, is you've got to build on stuff that you know is correct and works. You can't just have like magic and then stuff on top. Okay, I'm really going off here. I think maybe I need to not take myself so seriously. I'm going to get downvoted like crazy, but hey, at least you know I do really care about this, and this is why I get so passionate about this. Is I don't understand, and I think it's very dangerous. I think it's super, like, if it's just random lay people, and I don't mean that disrespectfully. I just mean, like, if it's somebody that is not a thought leader in some discipline, right? It doesn't matter as much if this person says stuff that just doesn't make sense, because people are not relying on that individual for the future and what to believe and what to do. But imagine if someone like Albert Einstein came out and said, actually, the world is flat. We all got it wrong. It's not round. Think about like the upheaval that could happen if that kind of scientific thought leader made that kind of grave error, right? There is this thing called scientific integrity. This is part of the reason why I created GTT. And again, it's not to be on a soapbox, but it's to say, like, I'm a lot of things, but I'm not drinking the Kool-Aid. I absolutely love AI, but I'm not going to ever try to convince people that it's something that it isn't. And if you want to use AI in hard science systems, then you really, at least to the best of my knowledge, you need to have a deterministic AI to work on the hard science things, because science is deterministic. Logic is deterministic. That's like the principle of it. You don't have these two states or these two expressions, and then you OR them together, and one time you get true, and then you do it again and nothing has changed, and then you get false. It doesn't work like that. It's always the same, right? So it's like the shirt is blue or it's green, and then you get an answer, right? Like, this is the shirt. The shirt is blue or it's green. False. We'll ask it again. It's false. You could ask that a bazillion times. That answer is always false. Why? Because first order logic is deterministic. It doesn't just sometimes say, welp, this time, true. Because if it did, then all of our stuff would just fall apart. And so this is really important, because if our scientific thought leaders start to like dissuade the public, if they start to, I'm probably gonna get in a lot of trouble for this VOD, but whatever, man. We're doing it. I'm gonna just watch the timestamp, and you'll see the minutes counting forward, and this will give you the clue that unedited. Yeah, it's just it. Part of me is, I'm going to be a little bit honest. I'm a little angry, and I try not to be emotional, and anger is an emotion, but I'm angry because some of these people know better. That's the part that makes me angry. I don't mind if there's some undergrad that doesn't really know stuff, and then they're like, I had a student this last year, and I was trying to explain, like, literally, it was actually kind of hilarious. Like 70% of my students dropped. I had, like, I don't know, 50, 60 students in my class, and I started and said, just so everyone's clear, I am not going to teach language models at all in this course. And in particular, that's because this is machine programming, which is about the automation of software. And principally, we need to use AI systems that are deterministic. So if you think you're going to learn language models in this class, you're in the wrong class. And literally 70% of students dropped. And that's crazy. That's crazy, because I don't even blame the students. I blame media. I blame the thought leaders. I blame the scientific minds out there that I'm talking about here, who know better. I know these people. I know they're very smart. I know they know what they're doing. And they should not do this. This is really dangerous. We've done this before, right? And Taylor and I talked about this. This is how you get to the Dark Ages. And if you think it can't happen, read a history book. It has happened. Look at, like the Spanish Inquisition, right? Look at a number of sort of these religious wars, right? and I'm not talking about any particular religion. I'm just talking about when belief and emotion trump reason, really bad things can happen. And so we should, in theory, be evolved enough. I mean, I would like to believe that we can do things based on what we kind of know is rationally correct. And clearly that's not the case, right? Again, part of the reason why we're doing GTT is to spread the goodness and get people to go back to a state of kind of using our minds rather than other things. And so, yes, this topic is a hot one for me. And so part of it is anger, and the other part is like sadness. Uh, it does make me actually pretty sad because, yeah, I'm trying really, really hard to foster goodwill. But I've even interacted with some of these folks and kind of said, yeah, like this isn't true, right? Like we can actually, we know that this is not right. Like maybe we should stop saying these things and just going to keep doing it because it's good for the company line or something. There's like a propaganda thing. And yep, this might be one of the main reasons why we have partnered with IBM is I do think that I'm not saying any company is perfect. No company is perfect. No human being is perfect. But minimally, I feel like I can have very rational, scientific, and sound conversations with the leaders at IBM and move forward in a responsible AI way. And that works for me because ultimately, my scientific integrity is one of my foremost concerns. I'm not going to do the hype thing. And there's no amount of money in the world that would ever get me to do the hype thing because ultimately, your reputation and your integrity is like the only thing you have. And the moment you lose this, again, I'm not saying I'm a perfect person. I've made tons of mistakes, right? But most of the things that I've done wrong in the past, it's like I didn't mean to do the wrong thing. I was just sort of an idiot. I think intentions matter. And if I know better, and in this case, I know better, I can't do the wrong thing because then people would be like, you didn't just do the wrong thing, Goju. You knew it was the wrong thing and you still did it. Now I'm not actually a good actor. Now my scientific integrity is gone. And no thanks. Nope. I've seen that before. I've seen how that plays out and not for me. Okay. I'm really going off on my soapbox today. This is, yeah, I'm probably going to get in some serious trouble, but we'll see. We'll see if GTT gets shut down tomorrow. Yeah, well, if anything, it's been entertaining, guys. Okay, I'm gonna mute myself and uh, let's hear what these two people have to say about prompt engineering. This concept of eventual consistency, I think, is a really good analogy of it is non-deterministic, but it's not really stochastic in the sense that it's not random. It's non-deterministic in that you don't know when the results will arrive, but they will arrive. And you will get to the same number whenever it settles. Whereas the stochastic ML systems, it's saying that you're going to get an answer, but it's anybody's guess what that answer is going to be. This is why it's not prompt engineering. It's prompt speculation because there's no amount of perfect prompting that you can give a stochastic system that's going to guarantee an output. It's not possible because it's a stochastic system. It's like
if I were to ask you, T, how you feel, and I ask you this.
By the way, I just want to add, this is not a complicated topic. This is not rocket science here. I'm talking like principles of logic. This is like foundations of logic. This is a philosophy 101 course here. This isn't like PhD level sliver off in the world where only 7 of us understand it, like me and interpretable metaphor when we're talking about typeless and folding, right? That is a very obscure, really complicated, super challenging topic. This, a 5-year-old could understand. Okay, this is not hard.
Question, the same question every day for a year. If you're a stochastic system, which you are, it would be crazy to think that the answer would be the same, even if my question is the same, because how you feel will change. So this is how stochastic LOMs are. It doesn't matter if your prompt is perfect. The stochastic model is going to give you whatever it wants to give you.
Another example of this, just to drive this point home, in something we saw in the last episode, and if you didn't see it, I encourage you to go back to it. I was interfacing with Perplexity, and I was asking it to give me a list of the top 50 movies for whatever. The first time it gave me 45 movies. Then I said again, you gave me 45 movies. I asked for 50. Give me 50. And then it gave me, I think, 42. So it's the same concept here, is that even with the same model, with an identical prompt, give me 50, give me 50. One time it gives me 45. That's not 50. The next time it gives me 42. That's also not 50, right? That's what you get with prompts. And that's why prompt text things are not engineering, because it cannot be done. Like, it is a fallacy. This is an illogical position to be in, because it's like it has no outcome. It's undecidable. You're just talking about unicorns and pink elephants floating in the sky. It just doesn't mean anything. You're just like saying words.
So it's not engineering. Engineering is following processes that are essentially repeatable, that give you some predictable output. That's not what LOMs are. And so it's not engineering. It's prompt something, but it's not prompt engineering. And so I'm sorry, whoever is saying that this is the next version of software, it's just more hype nonsense. And again, these are like, it may sound like these are my opinions, like, or I'm saying these with emotion because I probably am slightly maybe sad about how we've gotten to this state. I mean, that's sort of why I created Merly, is I couldn't kind of sit idly by it while I watched the world be destroyed by this greed.
Yeah, and I'm really going off here, but I do think that in some sense, a lot of it is greed. It really is just greed. It's that it's like a shiny new thing, and people want to cash in on it, and I understand in some sense, is like uh, it feels like it's an opportunity that you should execute on. But the truth is, like, these magic opportunities, that it doesn't really exist. I mean, they do, but they're not ones where like you just roll a 20 10 times in a row. It's that these magical opportunities, they exist when you have persevered and put in like a huge amount of work and committed yourself to a cause, and then you are meeting. So this thing with luck is opportunity that's met with preparation. Like that's what it is. And so the thing about this LOM thing, language only model, is you've got this opportunity that people see, but they have no preparation because they don't actually understand. Many of them don't understand AI or machine learning. They only just found out about it 7 seconds ago. And then and it's just like a race to see who can create the fastest, sloppiest thing. And I don't think that's, I don't know that that's going to get us to Mars type of thing. That might get you the next TikTok, but me personally, I'm not on TikTok, so I don't know what's going on in that world. So anyway, I think it's unfortunate that some of these things happen, and it's somewhat amusing to me because I've in some sense I've tried to warn people. You okay, buddy? He had a little cough. I tried to warn people about this, and a lot of them, unfortunately, I think just kind of leaned into the hype, and they've kind of put themselves in a world of hurt. And some of them have created companies that are just sort of pretendware. Other people have sort of like destroyed their credibility by saying things that or doing things that are just really quite dubious. And in some of the cases, the ones I'm talking about, they knew better. I'm not talking about the young folks that didn't know, right? Like those folks that are making those. There's generally two types of mistakes that happen. Generally, there's more than this, but this is one of the things I've learned. Generally, two types of failures. You have failures through lack of knowledge or competency, and you have failures through lack of care or effort. Okay. The failures through lack of knowledge or competency are almost always forgivable because somebody didn't know something. And then, of course, they're going to make that mistake because they didn't know better. And then you teach them, and then now they know, and then they don't make the mistake anymore. Right? Perfect. It's sort of like I learned how to play the audio, I think, on my computer. But I had to do it the wrong way once, and I didn't mute my mic. And so there's this weird echo, and I had to delete stuff, and certain parts of my video didn't come out. That was a failure due to lack of knowledge or competency. And then I gain the knowledge, I gain the competency, I don't make that mistake anymore. Or if I do, it's not a failure through lack of knowledge or competency. Like if I make that mistake in this video, that is a lack of care or effort, right? And so hopefully I won't make that mistake. Now, when you have people that then make the mistakes through lack of care or effort, those are the people that I'm talking about, that it's like they knew better. They knew this wasn't what it was cracked up to be, but they saw an opportunity to get rich quick. And there is no such thing. It's just make believe that there really are no shortcuts, that the only shortcut really is hard work. And that's not a shortcut. But then it actually is a shortcut, because when you do the hard work, that is actually the fastest path to achieve whatever it is you're trying to achieve. When you don't do the hard work, you may still get there, but you take 100x longer because you're all over the place. And then maybe after 10 years, you realize, oh, wow, if I just work hard, then I can do it. But maybe you could have figured that out a decade ago, right? So anyway, and I wanted to share, I was talking with some of my VC colleagues, and they were asking, can Murley's deterministic AI work in spaces other than just code? And I was telling them that, we're like a machine programming company, and our primary focus is really on code. But the way the system is designed is, I mean, in theory, there are pieces of it. I mean, it's designed to be generalized and abstract away. And so it doesn't have to be code, it doesn't have to be software code. It could be other things. There would be some fiddling. But I was asking the VC, well, why? Like, I don't think Murley's going to be pivoting from this. I mean, eventually we will start to dabble like in other domains, but I really like code. That's not to say that I haven't worked in other spaces, right? Like I've worked with large automobile manufacturers and built like temporal anomaly detection systems, like in our greenhouse paper, which if you look at, you can see that. And that works on data that is unstructured and ambiguous, like sensor data and stuff. That's not code data. So yeah. I mean, like, sure. But so I was asking the VC, like, yeah, we could do it. It would take work, but like, what's the question? And the point that this person was making is they were saying there's a number of companies that they're working with that they are essentially getting dead in the water now, that they're trying to use these language models and they're core to their system, but the results that they're getting are stochastic. Yet they're working in spaces where they need it to be deterministic. And so their systems are basically failing, that it's just not working for their customers. I mean, like this is not a "I told you so" moment. I'm not about that. It breaks my heart a little bit. This is though what I'm talking about is like these things are not actually that surprising for those of us that know what's going on. If you're new to this and you don't really understand AI or ML, this could be very jarring. It could be very confusing. And it's not your fault. It's the fault of legacy media. It's the fault of the hype that's coming out of one of the news outlets in Silicon Valley that I'm actually somewhat disappointed in. I've been talking to them and asking them to stop writing these articles that are just really kind of like disingenuous and promoting hype, and they keep doing it. And there will probably get to a point to where I'll just start openly criticizing their articles, like on GTT, and explaining why it doesn't work. Very much like we're doing with prompt engineering. And I'm not saying that as a threat. I'm saying like there's a limit to where I will tolerate the bad behavior before I feel like, okay, I need to be Batman now. And like, I need to do a little vigilante justice. So anyway, it's happening all over. And I think that we are on the precipice of a catastrophic failure for many of the companies that all they did was try to ride the language model hype train. And it's quite strange because it's so obviously not sufficient for hard science. Again, soft science totally works. Creative ideation absolutely works. Things where you want stochasticity, like generating a list of not 50 movies in some genre that may or may not even be in that genre, they are actually quite good at these things. So there's a number of spaces where these language models work extremely well. And in some sense, that's what they were designed for, right? Like language models, the part that they elide away, which is unfortunate, I almost wish they would just kept it in, is they're natural language models. That's really what they were primarily used for, right? With Google and their history of translation. right? It was rewriting Google Translate. I mean, there's many stories here, but Google Translate used to be, as I understand it, and I think Jeff Dean has spoken about this many times, that they used to have Google Translate. It was like 500,000 lines of code, and it had all these errors, but it was a whole bunch of rules. And natural language is ambiguous and it's nuanced, and the rules weren't perfect because natural language is like anybody's guess. Um, like I could say the sentence, "It's hot today." What do I even mean by that? Uh, am I talking about the weather? Am I talking about somebody's fastball? Am I talking about the stock market? All of those things are applicable for that sentence, right? This is the issue with natural language. It's like ambiguous. There's a bunch of different things it could mean. So using language models, natural language models, for natural language, pretty cool, because half the time we don't even know what the things that are being said mean, and then it's open to interpretation. It's kind of like why we stare at things like poems, and we have all these debates, and then somebody says, well, I interpret it this way, and somebody else is like, well, I interpret it this way, and everybody's right, because like, yes, in that space it is soft science, it is subjective, and all of those views could potentially be correct. uh Hard science doesn't work that way, guys. Right? Like, I know this is shocking. I know this is groundbreaking. And I'm sorry, I don't like to be sarcastic and snarky, but we're getting a little, I don't know. I'm a little spunky today. Um, yeah, maybe it's my EUC. Anyway, I need to take a short pause and refill the coffee. I think the dog's losing his mind, but I want to keep going for whatever reason. I want to talk a little bit about the EUC, intermittent fasting and stuff. So uh, give me a moment. I will be right back. Okay, we are back, although we lost the dog. But let's continue. So I think we've seen maybe enough of this. I wanted to actually, yeah, since we're talking about, I started to go down a little bit of a rabbit hole. And as I was creating the episode, analyzing Bill Daly and Jan LeCun talking, I reached out to Ryan Marcus, who's like we're talking about, one of my former students, and brilliant, truly, just amazing scholar. And it's like I'm really blessed to have worked with him, and I continue to try to work with him. I haven't, yeah, I apologize, Ryan. I haven't been working with you as much as I should be on some of the stuff. So we'll be fixing that soon. But I asked him to share his thoughts on what Daly and Jan were discussing, and I have his message back here, and I don't want to read it verbatim, but I did ask Professor Marcus if I could highlight some of the things that he raised, because I think that they're quite insightful. And so I want to just try to highlight some of those. So Professor Marcus points out that there's a separation between like the physical world and logical reasoning. And I absolutely agree with this, right? This is why I kind of sit more squarely in logical reasoning and not so much the physical world, because the physical world, I think it can be very non-deterministic and stochastic. I mean, I don't know that we understand all of the principles and aspects of that. And so I think that maybe we will one day understand all of that, but I think at least today we don't. And so Marcus is pointing out that he's not so sure that these are connected, and I agree with him. And that's actually very important, because if there is a separation, just if the system is logical and it does excellent reasoning, which I think those of us in hard science believe and think that these things are necessary for things like engineering, it doesn't necessarily mean that everything in the physical world will work correctly or follows these principles of logic, right? Like, for example, you could have airplanes and stuff that follow physical laws, and it's rooted in logic and mathematics. But humans are stochastic machines. They do stuff that, and they're not the only ones. Like, I think almost all animated life, any like biological life form, or many biological life forms, they can be unpredictable. Like, the dog just left me. Why did he leave? I don't know. The other night, he's like on top of me, trying to stop the whole recording. Stochastic machine, stochastic creature. So anyway, Marcus is pointing out that it's potentially orthogonal, this logic and reason and physical reality. I absolutely agree with this. And I'm more interested in the logical reasoning. I don't, maybe at some point we'll get into the physical world, but it's a disjoint thing. He does think that the memory and planning parts are critical, and I agree. I think memory is actually really important. Planning is really important. And he is saying that he thinks that the language model stuff and whatever, the things that we we give them names for, like chain of thought and context windows, are, yeah, not necessarily those things. And yeah, it's just, he's, I think, of a similar mindset that I'm in. And he does have a really interesting point, which I need to think about some more. And he actually is making an argument, which is that a sort of a vanilla attention mechanism could potentially be capable of handling continuous spaces. But it's the optimizations that we have enforced on language models and neural networks in general that restrict that capability, which makes it essentially not possible of doing the continuous spaces that I'm referring to and Jan's referring to. And I think that he might be right. And he's talking about how this is basically a manifold compression. And I think that he might be right. I'm not sure. I need to think about this some more. I mean, in a theoretical sense, I think that sort of makes sense. But from a practical perspective, I think I guess what I'm getting at is, if you didn't have like this manifold compression, which essentially moves a continuous space to discrete spaces that are finite, if you don't do that, I don't know that the networks have value anymore. I don't know. This is one of those things where I'll say I don't have enough data. I need to think more about this. This is an interesting idea, and we would need to think about this deeply. I think we're in a state right now where the language models and neural network architecture is essentially a discrete space, even if it has the feel of being a continuous space. It's actually not, for the reasons that Jan mentioned, the reasons that I mentioned, is that it transforms continuous spaces into a finite number of discrete outcomes. But Ryan might be right in that if you elided away those optimizations, then neural networks could be capable of working in continuous spaces. And then we would have to see, are they still useful? So I think that the word is still out on this one. The last piece that he shared, which I maybe I'll get close to reading verbatim. And by the way, Ryan, I think, was maybe at Jan LeCun's talk when he was visiting University of Pennsylvania a little bit ago. And so he was hearing other talks or talking directly to Jan. So, and Ryan, again, is one of those super up and coming, you know, he could be the next Alan Turing. He could be the next Einstein. So this is why I ask Ryan, what do you think? Because I'm very curious. He has no business being nearly as sophisticated scientifically, mathematically, engineeringly as he is for his age. But it's pretty incredible. I think a lot of determination. So Ryan's comment is, I'll just summarize. I won't read it verbatim. Is that he thinks that Jan's sort of like overstating some things, that LLMs are no longer interesting, and instead his views are similar to mine, which is that LLMs have value and they're the best thing that we have when doing like zero shotting types of problems. I think that's probably pretty accurate. And other things that are more nuanced, like image processing or dealing with text when you have nuanced spaces that are ambiguous. And I absolutely agree. I think that that's exactly right. I just wish people would use them in those spaces and stop like trying to treat everything like it's a nail now because they have a hammer. And so one of this last comment that he has is that he thinks they fall short in certainty. How confident am I that the LLM solved this task correctly? I've talked quite a bit about this, and using like Bayesian networks to do confidence ranking of the outcome. So certainty, surety. How confident am I an LLM can handle the task Y, which is similar to task X? That's actually quite interesting, which is different than the first one. And the last is refinement. Okay, this is good for a basic. Now evaluate and improve this. Then this last piece is the piece that I harp on quite a bit, is that language models in general really struggle with refinement, not only in them having an answer and refining it to become better, but also in refining the model so that, very different than like software code, which is one of its core qualities of software systems, which I think many people have been taking for granted, but they likely aren't taking for granted anymore, is that these software systems support iterative refinement. And iterative refinement are things like you can fix bugs and you just fix the bug. You don't introduce other side effects. The other thing that you can do with iterative refinement is you can make it faster. You can make it work in more platforms, more operating systems, more spaces. Another thing you can do with iterative refinement is you can add features. You can add features in a way that don't break the existing features. All of this is part of iterative refinement. And as I've mentioned numerous times, this is like the cornerstone of scientific advancement, that if you have scientific foundations that are not iteratively refinable, you're sort of cooked. You're basically like, science is, although science tends to be deterministic, at least the foundational principles that we use, they are constantly evolving. And they're evolving because we're learning more and we're adding. Sometimes we correct, we fix the bug, right? Like many of our early theorems are 97% correct, but this 3% we didn't get quite right. But we don't have to throw out the whole thing. We just need to fix these bugs and add special cases. Like if the value is 0, you can't use the division operator. Why? Because what does it mean to be divided by 0? Nobody knows. It could be anything. It just doesn't actually make sense. So, was that part of the original definition of division? I don't know. But I do know that for the number 0, division doesn't work. Does that mean that the principles of division are broken? I don't think so. I think the concept of division is actually pretty sound. It makes sense. Like, I have 9 of these things. How many groups of 3 exist in the 9 things? Makes sense. On the other hand, I have 9 of these things. How many groups of 0 do I have of these things? Now you can see it's like, I don't even understand what the question is. What do you mean groups of 0? You have an infinite number of those things. Or you have none. Like I don't know what the answer is, right? So these types of adjustments don't necessarily mean that the core mechanism of the theorem or the law are wrong. It's sort of like the addition of quantum physics to Newtonian physics. Again, I'm not a physicist, so don't trust me. I don't actually know what I'm talking about here. But maybe an example is like the C++ programming language. Does the invention of C++ invalidate C? No. No, you can still code in C. A lot of people do. I think C++ makes C better, but some people disagree with that. And so you can have this advancement and it doesn't violate this first thing. And in fact, a lot of people would argue that C++ never happens unless C happens first, right? So it's iterative. This is how we do stuff. It's iterative refinement. Like you really want, I think gets to the heart of the way that I try to solve these problems with software, or why I'm so growth oriented. I don't necessarily believe in this notion of like perfect solutions, that I'm going to have a setup for GTT and it's going to be perfect. And once I get it, it's never going to change. That's crazy. That's just pure lunacy. Of course it's going to evolve. Like, what about when 8K cameras come out? I'll probably be updating this camera. What about when faster computers come out? I'll probably do that. There's like a bunch of different things that I could be doing that could make this better. And so my goal is not to have a fixed solution for anything that I'm working on. My goal is to have a process in place, a system in place that is very easy to iterate on and adapt to make better. Very much like if you think about the 3 pillars of machine programming: intention, invention, adaptation. That adaptation piece is so critical because it's basically the entire space of, okay, we've got the thing now. most of the lifetime of stuff is now making it better, iterating. Like, truthfully, any piece of software, any piece of hardware that is not version 1 is a great example of this. The one that I tend to go to is like the iPhone. What are we on, like version 16 now? People still buy them. Apple claims that they're still getting better. What do we have? Windows 11? That's iterative refinement in practice. I mean, truthfully, while I complain about Windows 11, if I'm being honest, would I take Windows 11 over Windows ME or some of these other, like Windows 3.1, like going way, way, way back? Windows, yeah, I guess ME I already said. Windows 95 was not bad, 98. But like even those, I think if I were to see those today, I'd probably be appalled. So yeah, this is what you get when you have an iterative refinement solution. And that is what we have with software code. The idea that you would have LOMs that essentially would replace all software, that's just absurd. I mean, that's crazy talk because they lack the ability for iterative refinement. So that would mean that your LOM, which is the Windows operating system or the iPhone, it's done. You've one-shot it, and there's no updates, there's no revisions ever because you got it perfect. Who does that? Whoever creates the perfect anything? I mean, aside from certain things that have intentionality to be the final thing, like a Van Gogh painting or a Picasso thing, or maybe like a Beatles song, a Hemingway book, right? Even those go through iterations. But I mean, like once it's printed, the idea is sort of like, this is done now. But when it comes to software and hard science, it's iterative refinement, guys. I mean, that's the name of the game. That's why we keep evolving as a species. That's why we have things like flat panel TVs and Bluetooth and 4K webcams. We didn't have these things 20 years ago, right? I mean, we didn't even really have 4K TVs, much less 4K webcams. Nobody was like, I was actually watching Markiplier, my video game player guy, and he was playing this game, and it was a sequel. And he said, it's just out of coincidence, he said, the first version of this game was the first game I ever played on this channel. And you should check it out if you haven't seen it. So I checked it out. And this video was like 12 years ago. And it is, he's playing it, but there's something really interesting about this. He's not in the stream at all. It's just the video game. Why? At that point, we couldn't do webcam streaming, or at least we certainly couldn't do webcam streaming simultaneously while playing like a bleeding edge, cutting edge video game. Just, it wasn't possible with commodity hardware, but it is now. Iterative refinement. So if LOMs lack iterative refinement, how can they possibly be the next piece of technology that will be like disruptive as something like nuclear energy or the transistor or things like that? Like, think about the transistor and how much computers have evolved since the first. I mean, this is the whole Moore's law. Moore's law is simply the idea of adaptation and iteration. That's the whole premise. Is like, we've got this thing, but guess what, guys? We're going to make this better for the next 100 years. Things are just going to continue to get better. What does that story look like with language models? I can tell you what it looks like. It doesn't exist because they're stochastic systems, guys. Like, I feel like sometimes there's us that are living in like the logical world, and there's like everybody else that is like the flat earthers, and we're trying to tell them, guys, but it's not flat, it's round. and the sun does not rotate around us. And like, we can show them all the evidence in the world to try to compel them. They're just not buying it. And at some point, we just are like, okay, well, we still love you guys. Just stay away from stay away from the advancement of science. Like, please keep that stuff out of the foundations of technology. And this is where I do start to sort of defend my turf a little bit. Is I do take this stuff pretty seriously. I think that the scientific method is sort of it's foundational in the way that it can help us progress as a species, or many species moving across multiple planets and all this stuff, right? Because if we're going to Mars, I'm definitely taking a whole bunch of dogs with me, right? And so it's not just the human race. Like, if I help build the spaceship and we do this at Merle, that spaceship is going to have kennels, or there's going to be lots of doggy beds, minimally. And I'm going to be totally fine with people bringing their goldfish and their cats and all the other stuff that, their plants. Like, it's not just us, right? It's a lot of species. And the scientific method is foundational to helping all of us. I mean, yes, we've had some missteps, and sometimes we're a little over consumptuous, if that's a word, and we should probably reel that in. But I think that collectively we're trying to do better, and we are doing better. So the point is that there's certain things that are kind of like sacred, and they need to be protected in some sense. That you can't just come in and be like, let's all jive code, right? Like, what does this even mean? What is this? Like, you're just making up words that just don't mean anything, and somehow trying to pawn this off as people like this is the next new thing. But the truth is that the powers that be, they secretly know the only reason why they're doing it is just to make a buck. And that's not great. And I'll have a smile on my face, or I'll try to keep it lighthearted. I'll try to remember to do this part and not take myself too seriously. But there are certain hills that I will die on. This is one of them. This is protecting the advancement of science and making sure that we don't turn into idiocracy that some people seem to want to turn us into. I'm not gonna over my dead body, right? Like, hopefully, I'm sure I'm going to be getting to. I've actually, in running Nautica, I was actually talking with Taylor earlier today, and there's some stuff going on open source, and Taylor was saying that this person's getting death threats, and he's like, it's not good. And I remember thinking, oh man, I've gotten so many death threats, like just like water off a duck's back. This is why I was saying I'm completely unfazed. I'm ready for all the negative comments and stuff. Like, guys, I've been doing this for 25 years. I'm not new to the internet. I know a little bit about how this works. And yeah. So, but hopefully nobody acts on that. And they just they say things but don't do things. But anyway, if I suddenly stop showing up, we know that me trying to protect the sacred tomes of science and logic and reason, the powers that be saw me as an obstacle, and so they martyred me out of this. But if I'm no longer around, you guys keep fighting the good fight. Okay, don't let the human race turn into idiocracy. You've got to promise me, okay? Leave it in the comments and be like, I promise, Goju, we will not let us turn into idiocracy. Okay. We're at the 2-hour mark. We did talk about prompt engineering. That's cool. We did talk a little bit about Ryan Marcus. That's pretty great. I was going to talk about this fast code, secure code, all this stuff, but I don't know. We can get that next time. we did talk about the ketone IQ. Super. Oh, and yeah. So let me just share this last piece. One of the few hobbies that I have is I have my electric unicycle, and I absolutely love this thing. I'm in a former life I was a skateboarder, done a lot of mountain biking. I used to ski, and then I started snowboarding. I've been snowboarding for a while now, and I don't like. I enjoy snowboarding, but yeah, I'm older now, right? And it is like snowboarding and skiing is a little bit dangerous, and at least for me, it's not dangerous for the reasons that one might think. Is I'm not like an expert snowboarder by any stretch of the imagination. I'm actually mediocre at best, but generally speaking, I'm in control, and I can ski, snowboard the whole mountain for the most part. I don't go crazy. I don't really do too many tricks. Um, but the real danger is sort of the other people. And oftentimes with skiing and snowboarding, it's not the other people so much as it's new people, newbies that are a little bit out of control, doing stuff that maybe they shouldn't be doing, and they crash into you, or they come in and then you try to avoid them and you go off this edge. And then once in a while you get like thrown a curveball. Like I was in, yeah, there were 2 times where I ate it a little bit. And I'm always snowboarding and stuff with a helmet on and things. But one, I was in Tahoe and I was doing just fine. And I just hit an ice patch that I couldn't see. And I was carving. And the thing is about ice is you can't really carve on ice. And so, but I was already in the carve. And so I was carving and then I hit the ice and the board just slips out. And so I eat it. Thankfully, the helmet was on because I was coming right down on my head. So that was one. There was another time I was at Whistler, and great place, by the way. Whistler, so much better than Tahoe. If you haven't been there, check it out. But I was at Whistler, and we had this incredible fog. It was like this blizzard coming in, which is honestly a very cool time to ski and snowboard, but it does increase the danger. And the danger here was bad weather, and I'm old enough to know better. I'm just an idiot because I turn into like a 7-year-old kid and think, oh, this is so much fun. Like, it's just like we can't see anything and the snow's coming down. It's just so great. It's like a big party. And so I was just doing my snowboarding thing, not a care in the world. And I just went off this jump. Um, but I didn't know that I was going off this jump. And it's like I'm 15 feet in the air, which is normally not that big of a deal. But when you don't expect it, you're just suddenly in the air. Like, yeah. So I almost broke my wrist when I came down because I don't even know. Like, I can't see the ground. I didn't see the jump. I can't see the ground. I'm just flailing, trying to understand like what's going to happen next. And then I hit the ground and all my body weight like came down on my wrist. And thankfully I didn't break it, but I was like in a bad way. Anyway, what's the point of all this? Maybe my snowboarding days have, I feel like I can do things that still get me physical exercise that's fun, but less dangerous, where I can do fun, cool things, but I don't know. That second one is kind of my fault. But the first one with the ice and then like the people, uh, yeah, those might be hard to control. So now, maybe 3 years ago, yeah, 3 years ago, I discovered the electric unicycle. And what I liked about it is it felt similar to snowboarding in that it's all your feet. It's like your legs. Unlike skiing with poles and stuff, it's just your lower body. And I like that. Like there's something kind of special about a snowboard where it's just like you and the board and you have balance and stuff, but you're just connected. And so I saw the wheel as maybe similar. It's just me and the wheel. And when I first started doing it, like I'm just awful. Like if you try to, maybe if some of you have gone on EUC, you can share with others. But for me, it took a while to learn balance. It wasn't like I hopped on and I was an expert right out of the gate. It wasn't like that at all. And keep in mind, I even have this background as a skater, snowboarder, skier, all that stuff, and playing sports and stuff. So I'm not saying I'm athletic by any stretch of the imagination, but like I'm not it, I'm not like new to hand-eye coordination and foot-eye coordination, all that stuff. So after doing this for many weeks, several months, I finally got to the point to where it started to become more natural, and I just fell in love with it. And now I've been doing it for maybe about 3 years, and I'm always fully geared up. So I'm never, there's like a burly hair there. I think I got it. I'm never not protected. And keep in mind, like the EUC, it's very much like snowboarding or skiing. It's not a question of if you'll fall. It's just a question of when and how many times. And I did that a lot when I was first learning. I was bailing constantly and some pretty interesting bails. So it's good to wear the pads. Like if you decide to pick it up, either from listening to me or from other people, please make sure you always wear tons of pads, especially the helmet. Like that one's just really critical. But so I went on the EUC today, and I had shoulder surgery last year. It's mostly a thing that I did myself. It's nobody else's fault. It's me not having proper form, mostly from weightlifting, but also playing sports and stuff before then, specifically like throwing a football, throwing a baseball. So it was my left arm. But again, largely it was weightlifting and almost entirely self-inflicted. Like this is osteoarthritis. It's I did it to myself. But prior to the surgery, I really couldn't use my left arm. Like I couldn't even lift it up. Like I couldn't do this. It's just not possible. Um, and so I had the surgery last summer, and I'm still recovering. So it's, they say at least 12, 18 months, but I can move my arm again and I can be on the wheel again. And that's really helpful because when you're doing the balancing, especially as you get like more advanced stuff and you're going a little faster, you'll use your arms. And so I wanted to mention this because I was out there and I did, I don't know, maybe 25 miles or so today on the wheel. And it was pretty good. I mean, it was super fun and went on this awesome trail. And then I was using my arm for balance, and I got back, and when I was setting things up for this episode, I think I lifted my arm up, and I think it was from the use that I had on the wheel today, because I was like doing the airplane thing for balance and leaning and this kind of thing. So I'm swinging my arms around quite a bit more than usual. And so I was here and I did something, and I literally, I think, popped something in a good way. I think that like this is the process of re like learning how to use my arm and things getting adjusted. Is I think it wasn't quite adjusted right, because again I'm still not full strength. Like I can't really weightlift right now. A little bit, but it's, yeah, they have to cut through the tendons and stuff. The muscles are reattaching and all these things. But so I wanted to mention this because if you see me squirm or you see me like struggle, it's because of the shoulder thing. And I thought while I was talking about this, I might just, since we're in sharing mode, I thought I'd actually show you, just out of amusement, what this looked like before and after. And so what you're what you're seeing here, this is my shoulder uh, before the surgery. And I think maybe I had one of these, I might have closed it. I did have one of these windows that was showing like what a good shoulder looks like. And there's many things that are not super great with this. The first is it shouldn't be this close. Like basically all the cartilage that I have in this ball and socket joint is gone. And this is really what arthritis is, as I understand it, or osteoarthritis is basically just bone on bone. And at least for me, and I'm pretty tolerant of pain, this hurts. Uh, Bones against bones is, yeah, you generally want to have cartilage and stuff. And again, self-imposed. This is all me. This is Goju's fault here. It's me against me, and the outcome, that's on me. I did this, so I'm not blaming anybody. Then on top of that, you see this little thing down here. This is what they call like the goat's beard, and this is like bone spurs. This restricts movement. This, and like you can see, it's not round here. There's like these weird kind of shapes and stuff. This is all stuff that's problematic. Again, this is what happens when you do really rigorous weightlifting for a very long time with not great form, and you're young and stupid and think you're invincible, and you're not. And this happens. And it got to the point where the pain was just so overwhelming. I like had to get this fixed. And many of the doctors I went to were not super great. Again, my bar's pretty high, especially like if it's going to be surgery on me. But thankfully, I found Dr. Abrams, who is this incredible doctor out of Stanford Medicine, which makes it even better since we have a similar institutional loyalty, I guess. We'll leave it at that. And I think, yeah, he really took care of me. And so this is the before. I think, yeah, this is the overhead before, right? And again, as they were explaining, like this should be round, right? Like this stuff here, this is really not good, guys. This stuff is just bad stuff. Like it's not supposed to do that. And then it's not supposed to be up against like this. So yeah, my doctors, I had like a team of doctors, but Abrams is like the guy. And he works, I think, like on the San Francisco 49ers. So he really knows his stuff. And so that's that. And then that's this. And then after the surgery, this is where we are. And so this is my shoulder now. I highlighted this because they put a catheter in my neck. So I was just trying to figure out, I think, one point, like, what is this thing? And like, oh, that's a catheter that you had in your neck. So anyway, I now have a steel rod in my shoulder, and you can see too, like they cut this part off, and then they put this massive screw in there, and then they shaved off. Like again, remember in these other ones when we were seeing like there's this stuff here, and then there's this stuff here, like all of this stuff. That's this goat's beard. This like it stops you from moving it, right? Because that's like bone spurs, and oh, those bone spurs were so painful because they try to move your bone across the muscle, and it goes pop pop pop. I mean, it hurts like crazy. It hurts. And then you can see here, like, look at all this stuff. This is all of this, and how close it is on top of this. Like it's just bone on bone. And so now, this is my new shoulder. And so all that stuff shaved off. I've got this new thing, and you can see there's like significantly more space in here. I'm not sure exactly how they did all that. He also fixed, they reattached my bicep. I tore my bicep tenodesis, I think. And so they did multiple things. But I wanted to share this because if you see me squirm sometimes, like I'm trying to lift my arm and it's like a little strange, or if I'm on the EUC and I'm a little sluggish, like I am today, this is probably why. It's going to take probably another year or so before I'm sort of back to 100-ish. Well, when you have a surgery like this, I don't know that you really ever go back to 100%. But so back like when I was in my 20s, no. But compared to before the surgery, so my range of motion and strength and all that, it'll be actually significantly better. And I can already tell, like I couldn't literally do this before or hold my arm up like this. There's no way. This would be like shooting, crying pain. And so yeah, I'm pushing it, and sometimes I push it maybe a little too hard. And today with that popping thing, like, whoo, I don't actually know what that was, but it was pretty jarring. But I think something wasn't quite right, and I feel like it's better now. So I'm actually quite excited about that. But it hurt when I think something was just not quite in place. And my doctors were saying this is really common, that as you start going through more range of motion, you'll naturally run into these things. And I think it was the EUC today, because I was on it for like almost an hour and a half, and I'm doing like the airplane thing and other stuff. So anyway, we are over 2 hours now. We've talked about a bazillion different things. It's almost 2 a.m. I need to wrap this up and load this guy on YouTube. This has been super fantastic. There's still more stuff that I want us to talk about, but we'll get to this next time. So everybody, thank you for helping me judge people less harshly. I know I got a little bit judgy on this, but man, I just don't like when hype starts to try to pervert science. It's just not good. I'm just not too happy about that. But I'm going to continue to try to not take myself too seriously, except when we need to, because there are times. And if you haven't seen the Dungeons and Dragons movie, strongly recommend it. I'm blown away by how good it was, especially given that I'm a huge D&D fan. I thought it was going to be atrocious, as many of the ones before it were, and it was not. It was incredible. And we will, I think, continue to meander on the next one. I want to maybe look at some code and talk about a whole bunch of other things. Last but not least, check out this song, this techno song. Stay Oyoki, or Stay Oyok. So I'm butchering that. Anthology series, Whence We Came. It's about an hour and 15 minutes. Just found it today, at least for my taste. Masterful. Incredible stuff. Okay, folks. Okay, Jeters. You guys are amazing. More next time.